Most gardeners waste money buying seeds every spring, when saving their own could produce stronger plants and better harvests. A single tomato contains enough seeds for years of planting, yet seed packets keep selling because basic seed-saving techniques remain mysterious to many. The process looks complicated from the outside, but 10 specific tricks make it simple, reliable, and incredibly effective. These methods cover everything from choosing which plants deserve seed collection to storing seeds so they germinate perfectly 5 years later. Mastering these techniques transforms gardening from an annual expense into a self-sustaining cycle where vegetables improve themselves season after season. The first critical trick involves selecting only the healthiest, most productive plants for seed saving, as genetics pass directly from parent to offspring. Weak plants produce weak seeds that grow into weak vegetables, creating a downward spiral of declining garden performance. Instead, identifying the strongest specimens during peak growing season ensures superior genetics enter the seed collection. Plants chosen for seed saving should show vigorous growth with deep green foliage, no signs of disease or pest damage, early fruit production, and abundant yields. Marking these champion plants with colored ribbons or stakes during July and August prevents confusion later when dozens of plants look similar. A tomato plant that produces its first ripe fruit 2 weeks before others carries genetics for early maturity that will benefit future generations. Similarly, the pepper plant yielding twice as many fruits as its neighbors possesses superior productivity genes worth preserving. The selection process continues at harvest, as only the best fruits from these best plants should contribute seeds. Misshapen, small, or off-color fruits get excluded even if they come from excellent plants, because fruit quality also carries genetic components. This rigorous selection takes only minutes during regular garden visits, but compounds dramatically over years, creating vegetable lines specifically bred for local conditions. Research shows that even casual selection over 3 to 4 generations produces measurable improvements in plant performance. Understanding the difference between open-pollinated varieties and F1 hybrids represents the second essential trick, as this knowledge determines which seeds are worth saving. Open-pollinated seeds come from plants pollinated naturally through wind, insects, or self-pollination, producing offspring identical to parents generation after generation. These varieties, often labeled as heirloom or heritage seeds, maintain stable genetics that make seed saving practical and rewarding. Saving seeds from an open-pollinated Brandywine tomato produces more Brandywine tomatoes with the same flavor, size, and growth characteristics. F1 hybrids, by contrast, result from crossing 2 different parent lines to create vigorous first-generation plants, but their seeds produce wildly inconsistent offspring that revert to grandparent characteristics. A beautiful hybrid tomato might yield seeds that grow into plants producing tiny fruits, odd colors, or poor yields. Seed packets clearly indicate variety type, with terms like hybrid, F1, or F2, signaling unstable genetics unsuitable for saving, while heirloom, open-pollinated, or OP indicate stable varieties. This distinction matters enormously because hybrid seeds often cost more, yet cannot be saved, while open-pollinated varieties cost the same or less and provide unlimited future plantings. Some crops like lettuce, beans, peas, and tomatoes are almost always open-pollinated, making them ideal for beginners. Others like corn, cucumbers, and squash are frequently sold as hybrids, requiring careful catalog reading to find open-pollinated alternatives. Starting with guaranteed open-pollinated varieties eliminates the frustration of saving seeds, only to discover. The third trick focuses on harvesting seeds at optimal maturity, as timing dramatically affects germination rates and seedling vigor. Seeds collected too early lack fully developed embryos and may germinate poorly or not at all, while seeds harvested too late risk mold, rot, or lost to weather and animals. Each crop type has specific maturity indicators that signal perfect harvest timing. Tomatoes require fully ripe fruits, ideally slightly overripe with soft flesh but no rot, as seeds inside continue maturing even after fruits color. Leaving selected tomatoes on the vine an extra week beyond typical harvest timing ensures maximum seed maturity. Peppers need complete color change and the beginning of wrinkles on skin, indicating sugars have concentrated and seeds have hardened fully. Green peppers may look mature, but their seeds are actually immature and germinate poorly, if at all. Beans and peas must dry completely on the plant until pods turn brown and brittle, rattling when shaken, though this extends the growing season significantly beyond normal harvest. Cucumbers and squash intended for seed require weeks beyond eating maturity, growing until fruits feel rock hard and vines begin dying back naturally. Cutting these fruits open should reveal fully developed seeds with hard coats that resist fingernail pressure. Lettuce presents different timing, as seeds form in flower heads after bolting, requiring patience to let plants complete their full life cycle. The seed heads should dry until brown and papery, with seeds beginning to float away on small parachutes. Collecting too late means losing seeds to wind dispersal, while collecting too early yields immature seeds that won't germinate. Weather conditions affect timing too, as rainy periods can rot maturing fruits, while drought may halt seed development, requiring. The fourth trick involves fermenting tomato seeds to remove disease organisms and germination-inhibiting gel, a process that dramatically improves seed quality and storage life. Fresh tomato seeds come coated in gelatinous material containing germination inhibitors that prevent sprouting inside fruits, and this coating can harbor bacterial and fungal diseases that affect future plants. Fermentation mimics the natural process that occurs when tomatoes fall and rot on the ground, using beneficial bacteria to break down the gel while eliminating pathogens. The technique is simple. Scoop seeds and surrounding gel into a jar, add a small amount of water to create liquid consistency, and leave uncovered at room temperature for 2 to 3 days. During this period, beneficial bacteria multiply and consume the gel coating, while the mixture develops a thin layer of white or gray mold on the surface. This mold signals that fermentation is complete and seeds are ready for rinsing. Pouring the contents into a fine mesh strainer and rinsing thoroughly under running water removes all gel, dead material, and non-viable seeds that float away. The remaining viable seeds sink to the bottom and feel clean and smooth when rubbed between fingers. Fermentation should not exceed 4 days, as extended periods can trigger germination or damage seed viability. The process smells unpleasant, but not overwhelmingly so, and keeping jars outdoors or in a garage prevents odor issues. This technique applies specifically to tomatoes and occasionally tomatillos, while other crops like peppers, beans, and squash need no fermentation. Studies comparing fermented and non-fermented tomato seeds show fermented seeds have significantly higher germination rates and produce healthier seedlings. The fifth essential trick covers proper seed drying, as moisture content determines whether seeds survive storage or rot within weeks. Seeds must reach specific low moisture levels to enter dormancy and remain viable during storage, typically between 6 to 8% moisture content for most vegetables. Fresh seeds from fruits contain 30–50% moisture and will sprout, mold, or rot if stored wet. The drying process requires spreading cleaned seeds thinly on absorbent surfaces in warm, dry locations with good air circulation. Paper plates, coffee filters, or fine screens work excellently because they absorb moisture and allow airflow from below. Avoid using newspaper, as modern soy-based inks can stick to seeds, and some seeds may lift ink from the paper. Seeds should spread in a single layer with space between individual seeds, as clumping traps moisture and causes uneven drying. Location matters significantly, with indoor areas away from direct sunlight ideal because temperatures stay consistent and humidity remains low. Optimal drying temperature ranges from 70 or 85 degrees, warm enough to evaporate moisture quickly, but cool enough to avoid damaging delicate seed embryos. Direct sunlight can raise surface temperatures above 100 degrees, potentially killing seeds or reducing vigor. Air circulation from a nearby fan speeds drying without causing problems, though fans should not blow directly on seeds or they'll scatter. Drying time varies from 1 to 2 weeks, depending on seed size, humidity levels, and temperature. Seeds are sufficiently dry when they snap cleanly when bent, rather than flexing or bending, and they should feel hard and crisp with no soft spots. Storing even slightly damp seeds leads to rapid deterioration, so patience during drying prevents months. The sixth trick involves creating optimal storage conditions that keep seeds viable for years rather than months, extending the return on seed-saving efforts dramatically. Temperature, humidity, and light all affect seed longevity, with cool, dry, dark conditions preserving viability far longer than warm, moist, bright storage. The ideal storage temperature ranges from 35 to 40 degrees, making refrigerators nearly perfect storage locations. Seeds stored at room temperature lose viability much faster, with germination rates declining noticeably after just 1 year for some species. Freezing works well for long-term storage, though seeds must be completely dry before freezing to prevent ice crystal damage to cell structures. Humidity proves equally critical, as seeds absorb moisture from air and storage life drops dramatically at high humidity levels. Paper envelopes provide better storage than plastic bags because paper breathes and prevents moisture accumulation, though plastic works fine in consistently dry conditions. Glass jars with tight sealing lids create excellent storage environments, especially when kept refrigerated. Adding food-grade silica gel packets to jars absorbs any residual moisture, maintaining the dry conditions essential for seed longevity. These desiccant packets can be regenerated by heating in an oven when they become saturated, providing reusable moisture protection for years. Light exposure degrades seeds through chemical reactions that break down storage proteins and lipids, so opaque containers or dark storage locations prevent this deterioration. Organization systems save time and confusion, with seeds grouped by crop type and variety, then arranged alphabetically or by planting date. Detailed labeling proves absolutely essential because seeds of different varieties often look identical, and memory fades over months. Each packet or jar should clearly show the variety name, harvest date, and any notable characteristics like earliest producer or disease resistant. Some gardeners include growing notes about spacing, days to maturity, and preferred growing conditions. The seventh trick involves testing germination rates before planting season to avoid disappointing results from old seeds. Seeds don't maintain 100% viability forever, and germination percentages decline gradually over years, even under perfect storage conditions. Testing reveals exactly how many seeds from a collection will actually sprout, allowing adjustment of planting quantities. The process is simple. Count out 10 seeds of each variety, place them between damp paper towels, and seal in a plastic bag or container to maintain moisture. Check daily and count how many seeds germinate within the typical germination period for that crop, which varies from 3 days for radishes to 2 weeks for peppers. If 8 out of 10 seeds sprout, the germination rate is 80%, and planting quantities should increase by 25% to compensate. Rates above 80% indicate excellent viability. 60-80% suggests seeds are aging but usable, and below 60% means seeds should be discarded or used very heavily. Different crops maintain viability for vastly different periods, even under identical storage conditions. Tomato seeds commonly remain viable for 4 to 6 years, cucumber and squash for 5 to 10 years, beans for 3 to 4 years, lettuce for 3 to 5 years, and peppers for 2 to 4 years. Onion seeds are notoriously short-lived, losing viability after just 1 to 2 years regardless of storage quality. These timelines assume proper storage at cool temperatures and low humidity, while poor storage can reduce viability to a single year even for long-lived species. Regular testing every fall before spring planting prevents the frustration of waiting weeks for seeds that will never sprout, wasting both time. The 8th trick covers preventing unwanted cross-pollination that compromises variety purity, especially important for insect-pollinated crops. Cross-pollination occurs when pollen from one variety fertilizes flowers of another variety, creating mixed genetics in the resulting seeds. The extent of this problem varies enormously by crop type based on pollination mechanisms. Tomatoes are highly self-pollinating with flower structures that prevent most cross-pollination, making them ideal for beginners who can grow multiple varieties in close proximity safely. Peppers self-pollinate primarily, but bees occasionally transfer pollen between plants, creating 5 to 10% crossing rates when different varieties grow within 50 feet. Increasing this distance to 100-200 feet reduces crossing to negligible levels for home seed saving. Squash, cucumbers, melons, and pumpkins present major challenges because they require insect pollination and cross readily within species. Different varieties of summer squash, zucchini, acorn squash, and many pumpkins all belong to Cucurbita pepo and will cross-pollinate at high rates up to half a mile away. Growing only one variety per year prevents this issue, or hand pollination allows multiple varieties by controlling which pollen reaches which flowers. The hand pollination process involves identifying female flowers by the small fruit at their base, covering them with mesh bags before they open in the morning, then manually transferring pollen from male flowers using a small brush or cotton swab. Marked hand-pollinated fruits produce guaranteed pure seeds. Beans are self-pollinating and rarely cross, while corn is wind-pollinated and crosses extensively, requiring quarter-mile isolation and large populations to prevent inbreeding. Understanding these differences prevents wasted effort saving seeds that produce unexpected mixed varieties. The 9th trick transforms basic seed saving into active plant breeding through deliberate selection that rapidly improves varieties. Rather than simply saving seeds from any healthy plant, choosing seeds only from plants showing the most desired characteristics drives genetic progress visible within 2 to 3 generations. Selecting for specific traits requires identifying what matters most in each crop. Early maturity can be enhanced by saving seeds exclusively from plants producing ripe fruits before all others, gradually shifting the variety's genetics toward earlier harvests. Studies show this selection can advance maturity by 1 to 2 weeks per generation, allowing northern gardeners to adapt long-season varieties to shorter growing periods. Size selection works powerfully by consistently choosing the largest fruits from the largest plants, as both fruit size and overall plant vigor have strong genetic components. Flavor proves harder to select because it requires tasting many fruits, but saving seeds from the best flavored specimens does concentrate flavor-producing compounds over generations. Disease resistance responds beautifully to selection, as eliminating any diseased plant from the seed-saving pool removes susceptible genetics from the breeding line. Even one season of rigorous disease selection noticeably improves resistance in the next generation. Plant architecture can be modified by selecting compact, bushy growth over sprawling habits, or vice versa depending on needs. Maintaining detailed records about which plants get selected and why creates a breeding history that reveals patterns and documents progress. Some dedicated seed savers grow 5 to 10 plants of each variety specifically for seed production, selecting only from the absolute best 1 or 2 performers. This intensive approach can create truly unique varieties over 5 to 7 years that are perfectly adapted to individual gardens and genuinely. The 10th and final trick recognizes when purchasing commercial seeds makes more sense than saving, balancing self-sufficiency with practical limitations. Biennial crops, including carrots, beets, onions, cabbage, broccoli, and most root vegetables, require 2 full growing seasons to produce seeds, first forming their edible part, then overwintering before flowering and setting seed the second year. This extended timeline and space requirement makes seed production impractical for many home gardeners, especially those in cold climates where overwintering root crops proves challenging. These crops are often better purchased as seed annually while focusing saving efforts on quick-producing annuals. F1 hybrid varieties sometimes offer specific disease resistances unavailable in open-pollinated types, making them valuable despite their unsavable seeds. Gardens plagued by Fusarium wilton tomatoes benefit from resistant hybrids even if new seeds must be purchased each year. Starting new crops or trying unfamiliar varieties obviously requires initial seed purchases before any saving can begin, and these purchases should target reputable companies selling open-pollinated or heirloom varieties suitable for future saving. Certified disease-free seed potatoes prevent introducing soil-borne pathogens that persist for years, making their purchase worthwhile even though potatoes can theoretically be saved. Crops requiring extensive isolation like corn, or those needing large populations to prevent inbreeding, may be impractical to grow for seed in typical home gardens. Purchasing from specialty seed companies preserving rare heirloom varieties supports important conservation work and introduces genetic diversity that prevents the problems of repeatedly saving seeds from the same small plant population. The goal is not eliminating all seed purchases, but rather developing a sustainable system where most needs are met through saving, while strategic purchase. These 10 seed-saving tricks work together to create a self-sustaining garden system that improves year after year while reducing costs and increasing food security. Starting simple with 1 or 2 easy crops like tomatoes and beans builds confidence before expanding to more challenging vegetables. The skills develop quickly, and the results become visible within just a few growing seasons, as saved seeds produce stronger plants, better adapted to local conditions. Try selecting the best tomato plant this season, saving its seeds carefully, and planting them next spring to see the difference.